Okay, so here is an example question. It's a little bit complicated. What is pH of a 1250 milliliter solution containing 5 grams of sodium hydroxide and 5 grams of barium hydroxide? Both are strong bases. So we have to be able to pick apart this problem. One of the first things we have to realize is strong base means they completely dissociate. So the sodium hydroxide will break apart into sodium and hydroxide ions. The barium hydroxide will completely break apart into barium and hydroxide ions. We particularly need to pay attention to the formulas. So for every compound that's sodium hydroxide, we'll get 1 hydroxide ion. For every compound that's barium hydroxide, we'll get 2 hydroxide ions. So the first thing we're going to have to do is find the moles of those 2 compounds. The moles of hydroxide from sodium will be the same as the moles of the compound, but for barium hydroxide, we'll have twice as many moles of hydroxide as moles of the compound. Then we have to keep moving. Moles isn't going to work by itself. So we're going to add the moles of hydroxide from the 2 compounds together, divide them by the volume, but we'll have to convert it to liters. And what that will do is that will give us the concentration of the hydroxide ions. Now, the best way to do this, simplest, is to then find the pOH of that solution, subtract it from 14, and that will give you the pH. So let's start going through step by step. Okay, so here you can see that I went ahead and looked up the molar mass and added it up for sodium hydroxide, which is 40 grams per mole, and for barium hydroxide, which is 171.35 grams per mole. Then I calculated the moles of sodium hydroxide by dividing, the grams by the molar mass as per usual. And I did it for both sodium hydroxide and barium hydroxide. Now you might be saying, well, why did I leave an extra sig fig for the barium hydroxide? Well, I'm going to carry these numbers forward in my calculator, so I'm not going to round down at this step. Now, these moles are not moles of hydroxide. They're moles of compound. So we have another step before we can find the moles of hydroxide. We're going to have to multiply sodium hydroxide by 1, so it's the same there in that case. And then we're going to have to add it to the moles of barium hydroxide multiplied by 2. Why? For every 1 compound, you have 2 hydroxides. So to get the right amount, you have to multiply by 2. Okay, so this shows how to find the moles of hydroxide from the 2 compounds. So you multiply the one from sodium hydroxide by 1, you multiply the one sodium hydroxide ions from the barium hydroxide by 2, add them together. So the moles of hydroxide is going to be 0.18336 moles. Again, I'm not rounding down. I'm not going to round down till the end. And almost certainly we're going to end up rounding down to 3 sig figs, which is because we started with 5.00 grams of each. Now, to find pOH, we have to know the concentration. So we have to take the moles and divide it by the volume of the solution. So since we know it's 1,250 milliliters, we convert it to liters and then take our moles of hydroxide and divide it by that. So right now we've got 0.14669 moles of hydroxide per liter or molar solution. So the next step is to find the pOH, subtract that from 14, and we'll get the pH. And because we know we're going to have 3 sig figs, we will have, after the decimal point of the pH value, 3 digits. Okay, so using the value for the concentration that we found previously for the hydroxide ions, we find the pOH, which is just minus log of the concentration. The pOH is 8.834. Now at this point, we're going to round it down to 3 because we know our answer has to have 3. So we're going to go ahead and round it to 3. And then in order to solve for the pH, we use the equation pH plus pOH equals 14. Remember, 14 is an exact number. And so the pH will be 14 minus 0.834, which is 13.166. Remember, pH above 7 means that it's a basic solution. So this makes sense. It's a very, very basic solution. All right, so that's how you solve it. That should help you answer some of the harder questions on the worksheet.